Now coming to the sum of the roots and product of the roots of a quadratic equation. Now for example, if we consider this quadratic equation ax square plus bx plus c is equal to 0, and you are asked to find the sum of the roots and product of the roots, then do we have to determine the roots? And then for example, if I consider alpha beta as the roots of this equation, shall we solve for alpha and beta? And then after finding the values of alpha and beta, alpha plus beta and alpha beta, isn't it? So to answer this question or to find sum and product of the roots, do we have to solve for the roots, or do we have any direct formula which gives us the sum and the product of the roots? Okay, so if you are given with any quadratic equation and if you are asked to calculate the sum and product of the roots, no need to determine the roots of that equation. Okay, so you can find the sum of the roots of the equation by this formula minus b by a, and product of the roots by the formula c by a, where b is the linear coefficient. So coefficient of x, we call this to be linear coefficient, and a is quadratic coefficient, and c is the constant. So sum of the roots are given by minus b by a, and product of the roots are given by c. Clear? Now given with sum of the roots and product of the roots. For example, if I consider alpha and beta to be the roots of this a quadratic equation, we are given that alpha plus beta is equal to something. Okay, alpha beta is equal to something. For example, alpha plus beta is equal to 3, and alpha beta is equal to 2, for example. Okay, so you are asked to find the quadratic equation whose roots are alpha and beta. Now to answer this question, do we have to solve for alpha and beta and then find the quadratic equation which is x minus alpha into x minus beta is equal to 0, or do we have any other shortcut using the sum and product of the roots? Now let's see. Okay, for example, if I consider p and q are the roots of an equation, p and q are the roots of an quadratic equation, then can I say x minus p into x minus q is equal to 0? Now if you expand this, you will be getting x square minus p plus q into x plus pq is equal to 0, isn't it? Now what is this p plus q? Okay, considering p and q as the roots of that equation, p plus q is nothing but the sum of the roots, and pq is nothing but the product of the roots. So given with sum of the roots and product of the roots, we can frame the quadratic equation like the quadratic equation whose roots are p and q will be x square minus sum of the roots into x plus product of the roots is equal to 0. Clear, guys? Now, okay. So in this question, we are given that if the quadratic equation 4x square minus kx minus 4 is equal to 0 has sum of the roots as 1, we need to find the value of. Okay, so compare this with ax square plus bx plus c is equal to 0. Now sum of the roots is nothing but minus b by a. So here it will be minus of minus k. So the value of b is minus k here, and by the value of a is 4, and this is given to be 1. So this implies k should be equal to 4. So the answer for this question should be 4, guys. Clear? Now moving ahead. Find the value of b if x plus 3 into 2x plus 5 is equal to 2x square plus bx plus 15. First, okay, one way of solving this question is just expanding. If you expand, you will have 2x square plus 6x plus 5x plus 15, isn't it? Compare this with 2x square plus bx plus 15. So this is nothing but 2x square plus 11x plus 15. So comparing these equations on both sides, you can find the value of b is 11. Isn't this is one way of doing it? Otherwise, okay, if x plus 3 and 2x plus 5 are the roots of this equation, so if I equate this to 0, okay, the roots of the equation will be minus 3 and minus 5 by 2. And sum of these two should be equal to minus b by 2. So this is nothing but minus 6 minus 5 by 2 is equal to minus b by 2. Or this implies minus 11 by 2 is equal to minus b by 2. B is equal to 11. So the answer for this question should be 11. So you can solve using any of these two methods, guys. Clear? Now, moving ahead. So in this question, the given equation is x square plus 8x minus 9 is equal to 0. The roots are alpha and beta. We need to find the value of alpha by beta plus beta by alpha. Okay. So one way of doing this is finding the roots of this equation. Let the roots be alpha beta. For example, the roots of this equation will be x square by using factorization method. X square plus 9x minus x minus 9 is equal to 0. So x into x plus 9 minus 1 into x plus 9 is equal to 0. So the roots of this equation will be 1 comma minus 9, isn't it? So the value, let us consider the value of alpha as 1 and beta as minus 9. So 1 by minus 9 plus minus 9 by 1. So this is nothing but minus 9 or 9 minus 1 minus 81. So this will be minus 82 by 9. So this is one way of doing this. Solving this question, finding the value of alpha and beta, and then substituting the value of alpha beta in the given expression. Okay, so the second way of doing this is when I look at alpha by beta plus beta by alpha, the first thing I will do is I will take the LCM of this. So you will be getting alpha square plus beta square in the numerator and alpha beta in the denominator. So using algebraic identities, I can write alpha square plus beta square as, this can be written as alpha plus beta whole square minus 2 alpha beta by alpha beta. Or this can be written as alpha plus beta whole square by alpha beta minus 2. So alpha plus beta, this is nothing but sum of the roots. So minus b by 8. So this will be minus 8 whole square by product of the roots c by a minus 9 minus 2. So this is 64 by 9, sorry, minus 64 by 9 minus 2. So 64 minus 64 minus 18. So this will be minus 82 by 9. So you can solve this question in any of these two ways. Clear? Now moving ahead. So in this question, it is given that 4 plus root 5 is a root of the equation x square minus 8x plus k is equal to 0, where k is a rational number. Find the value of k. Okay. Now 4 plus root 5 is a root of this equation, and it is given that k is a rational number. So product of two roots. So 4 plus root 5 into the other root, let us say alpha, is a rational number. Now what can we say about this? This alpha should be rationalizing factor or conjugate of this number, isn't it? So I can say that alpha should be in the form k into 4 minus root 5. So then only you will get k as a rational number. So when can we get a rational number? By multiplying something with a surd. So when a surd is multiplied with its conjugate, then only we will be getting a rational number. Okay, so I can say that the second root of this equation will be in the form of k some constant into 4 minus root 5. Okay, okay, it was given k in the question, so let me consider this as p, some p into 4 minus root 5. And what is the sum of the both the roots? Minus b by a, minus 8 minus of minus 8 by 1, so sum is 8. So 1 root is 4 plus root 5 plus 4p minus 4 root minus p root 5, sorry, minus p root 5 is equal to 8. Okay, so again sum of two roots and we do have a rational number here, so these two should get cancelled and the value of the rational part should be 8. So this is possible only when the value of p is equal to 1. Okay, so p is equal to 1, so the second root will be 4 minus root 5. So k is nothing but product of two roots. So 4 plus root 5 into 4 minus root 5 is equal to k. So 16 minus 5, the value of k will be equal to 11. So the answer for this question should be 11. Clear? Now coming to nature of roots. Okay, so we have discussed two ways of finding roots. One is using factorization and the second one is using formula. So what is the formula to calculate the roots of any quadratic equation? Minus b plus or minus root of b square minus 4ac by 2a. Here b square minus 4ac is called the discriminant, and let's understand the importance of this discriminant. Okay, so we will be considering b square minus 4ac. Now what will happen if this is less than 0? If the discriminant is less than 0, so you will be having minus b plus or minus some negative number by 2a. Now square root of a negative number, will that exist? Can we find the square root of a negative number? No, that will be an imaginary number, isn't it? You cannot have square root of a negative number in our number line from minus infinite to plus infinite. Okay, so whenever we have the discriminant is less than 0 or if the discriminant is negative, both the roots will be complex or there will not be any real roots of the quadratic equation. And we have discussed that the graph of a quadratic equation will be a parabola. It can be an upward parabola or downward parabola, upward facing parabola or downward facing parabola. Okay, now when there are no real roots, okay, so the parabola will be either like this or like this. Okay, because when can we say that there will be roots of an quadratic equation? You should be having points touching x-axis, isn't it? So the equation of x-axis is y is equal to 0. So at these 2 points, the value of that quadratic equation is 0. So if this is x1 and this is minus x2, then x1 and minus x2 are called the roots of that equation. Okay, so when a discriminant is less than 0, okay, that means that the given parabola will not touch x-axis or there will not be any real roots for that equation. So I want you guys to understand it technically, also graphically. So this is the meaning of that statement. Now, okay, what will happen if discriminant is 0? If this value is 0, the root will be minus b by 2a, isn't it? So both the roots will be equal, they will be real and they will be equal. Okay, and that quadratic expression will be in the form of k into x minus a whole square, where a is the root of that quadratic equation, isn't it? For example, Okay, so the graph of that quadratic equation will be somewhat like this. So it will have only one root. Okay, so at this point, at only this point, okay, the value of that quadratic equation will be 0. For example, if this x coordinate is x1, okay, at x1, when the value of x is equal to x1, the value of the quadratic equation will be 0, or the graph of the quadratic equation meets the y-axis, meets the x-axis at only one point. Okay, this is when discriminant is equal to 0. Now, discriminant is a perfect square. So if discriminant is greater than 0 and a perfect square, so when this is greater than 0 and a perfect square, you will be having a definite value for this, a rational value. So it will be in the form of minus b plus or minus some r by 2a. So in that case, both the roots will be different. So one root will be minus b plus r by 2a, and the other root will be minus b minus r by 2, where r is nothing but the square root of the discriminant, isn't it? So you will be having two real roots which are rational but unequal, isn't it? Now when this is greater than 0 and if it's not a perfect square, so if it's not a perfect square, this will be an irrational number. So minus b plus, it will be in the form of root of some, let us say, I by 2a. This will be one root, and minus b minus I by 2a. This will be one root. Both the roots will be irrational and they will be conjugate. So if you can observe that these two are conjugate. So if you multiply them, you will be getting a rational number. Clear, guys? Any doubts? Quick responses. So you need to understand that when discriminant is less than 0, the roots are always complex or imaginary. When discriminant is equal to 0, the roots are real and equal. When the discriminant is greater than 0 and a perfect square, then the roots will be rational and unequal. When the discriminant is greater than 0 and not a perfect square, they will be irrational and conjugate. Okay. Now if it is given that the roots of this equation x square minus kx plus 49 is equal to 0 are real, what values can k take? Okay. So given that x square minus kx plus 49 is equal to 0 have real roots, can I say that b square minus 4ac should be greater than or equal to 0? Isn't it? So this should be greater than or equal to 0. Okay. So the value of b is minus k. So minus k whole square is k square minus 4 into 49, which is 196. This should be greater than or equal to 0. So k square should be greater than or equal to 196. So this implies two possibilities. So the value of k should be greater than or equal to 14, or the value of k should be less than or equal to minus 14. So this you will come across in inequalities. So don't worry. You learn this in inequalities as well. Clear, guys? So the values of k will be minus infinite to minus 14 inclusive union 14 to infinite. Clear, guys? Now coming to the next question. Now if the value of p is real in x square plus 2 into p plus 1x plus 2p is equal to 0, the nature of roots will be. So whenever you're asked question about the nature of roots, the first thing that should strike your mind is discriminant. We can determine the nature of roots by using discriminant only. So compare this with ax square plus bx plus c is equal to 0. Okay, so the value of b here is 2 into p plus 1. So b square Okay, so B is 2 into P plus 1, A is equal to 1, and C is equal to 2P. So we are asked to determine the nature of roots. Okay, so for that we need to determine P square, B square minus 4A. So 2 into P plus 1 whole square minus 4 into 1 into 2P. So this is equal to 4P square plus 4 plus 8P minus 8P. Okay, so these two will get cancelled and we will be having 4 into P square plus 1. So discriminant is 4 into P square plus 1. So this is always positive, isn't it? So the roots of this equation will be real and unequal, because this cannot be 0. This cannot be 0. So P square plus 1 will always be a positive number only. So the root should be real and unequal, isn't it? The roots can be either rational or irrational. So if the value of P is equal to 0, then this will be a perfect square. 4. Okay, the value of P is let us say 2, then it's not a perfect square. Okay, then the roots will be irrational. Clear, guys? Now coming to the next question. Okay, so here A is a single digit prime number and B is a natural number. So how many equations of the form x square minus 4 root ax plus 3b is equal to 0 will have real roots? So to have real roots, discriminant should be greater than 0. Okay, so compare this with ax square plus bx plus c is equal to 0. So a is equal to 1, b is equal to minus 4 root a, and c is equal to 3b. So the discriminant will be b square. So 16a minus 12b. This should be greater than 0, or this should be greater than, or it can be or equal. Okay, so 16a should be greater than or equal to 12b, or a by b should be greater than or equal to 3 by 4. And given that a is a single digit prime number, so the values that a can assume will be 2, 3, 5, 7. Now when a is equal to 2, okay, what can be the value of b? The value of b can be and natural number. So b can be 1, b can also be 2, uh, can b be 3? Can we have the value of b as 3? No, not possible, isn't it? So you have two values for b when a is equal to 2. Now if I consider a is equal to 3, so this can be 1, 2, 3, and 4 as well. Okay, now when the value of a is equal to 5, 1, 2, 3, 4, 5. Can we have the value of b as 6? So 16 5 is 80. So 12 6, 72 years. Can we have the value of b as 7? 12 7 is 84 months. Now when the value of a is equal to 7, so you 1, 2, 3, 4, 5, 6, 7. Can the value of b is equal to 8? So 16 into 7 is nothing but 112. Yes, 12 8 is 96 and 12 9 is 108. Okay, so these are the values of p corresponding to the respective values of a. So when a is equal to 2, you have two values. You can frame two equations. When a is equal to 3, you can frame 4 equations. When a is equal to 5, you have 6. And when a is equal to 7, you have 9. So 2 plus 4, 6, 6 plus 6, 12, 12 plus 9, 21. So you can frame a total of 21 equations in the form x square minus 4 root ax plus 3b is equal to 0, such that a is a single digit prime number and b is a natural number. Clear, guys? Now, moving ahead. Now I have a question for you guys. So till now we have discussed the questions based on finding the roots of an equation. Okay. Given with sum of the root or given with roots framing an equation, given with sum of the roots and product of the roots framing an equation. Okay. Now if I give you a quadratic equation which is in the form of, let us say, ax square plus bx plus c is equal to 0, and if I tell you that there is one more equation in the form of px square plus qx plus r is equal to 0, whose roots are one more than this, one more than the roots of this equation, or one less than the roots of this equation, or half of these roots, then can we determine the equation px square plus qx plus r is equal to 0? Can we frame that equation? Or let us say you are given within quadratic equation in the form of ax square plus bx plus c is equal to 0, and you are asked to frame another equation whose roots are one more than the roots of this equation, ax square plus bx plus c. Then how will you be doing that? Okay, so one way is finding the roots of this equation ax square plus bx plus c is equal to 0. Now, for example, if p and q are the roots of this equation, okay, so the roots of the another equation will be p plus 1 and q plus 1, or p minus 1 or q minus 1. So let us consider one more than. Okay, so the roots of the other equation will be p plus 1 and q plus 1. So the other equation will be in the form of x minus p plus 1 into x minus q plus 1. Okay, so you will be getting the new equation whose roots are one more than the roots of ax square plus bx plus c is equal to 0. But I consider this to be a time taking method, isn't it? So because you need to first find the roots of that equation, add the number, and then again you have to frame another equation, isn't it? So instead of that, you can just follow this table. So if we are given with that, if alpha beta are the roots of the quadratic equation ax square plus bx plus c is equal to 0, and if you are asked to form a new equation like the roots of the new equation are p more than the roots of the old equation, then the only thing that you need to do is replace x with x minus p. That's it. In this equation, just replace x with x minus. So if it is given that the roots of the new equation are p less than the roots of the old equation, replace x with x plus p. Okay, if the roots of the new equation are p times the roots of the old equation, then replace x with x by p. And if you are given that 1 by the new roots of the new equation are 1 by p times the roots of the old equation, then replace x with xp. And if the roots are reciprocal to each other, means if the roots of new equation are reciprocals of the old equation, then the new equation will be this cx square plus bx plus a is equal to 0. So if you can remember these 5 identities or formula, or you can call them anything, okay, they might save you a lot of time in quadratic equations. Clear, guys? Now moving ahead to some questions based on this model.